Hello friends, let's solve summer 2025 IGCSE MCQ component 2 physics. Okay, which instrument is most suitable to determine the value of a small shaped stone? Measuring cylinder. C. Steel ball is dropped from top floor of a building. Air resistance can be ignored. Which statement describes the motion of the ball? Okay, so in free fall, objects actually fall with constant acceleration. So it has a value 9.8 meter per second square. Okay, so the velocity increases every second by 9.8 meter per second. That's why it's 9.8 meter per second square. So it's with constantly increasing speed. So what we have here? Option A, ball falls with constant acceleration. Only if air resistance is equal to the weight of the ball, then terminal velocity is reached. There, the ball falls with constant speed. Yes. The diagram shows the velocity time graph for an object which is accelerating. What is the acceleration of the object? In velocity time graph, acceleration of the object is just gradient of the curve. So we need to take 2 points from the curve. So I'm going to take 0, 20 and 40, 120. You can take any points, but taking points from the edges for easy calculation in on the axis. So we will find gradient by y2 minus y1 divided by x2 minus x1. And it's 2.5 meter per second square. Option B. Diagram 1 shows a piece of flexible material that contains many pockets of air. Diagram 2 shows the same piece of flexible material after it has been compressed so that its volume decreases. What happens to the mass and to the weight of the flexible material when it is compressed? Okay. Now, first, mass is independent of shape and size. Okay. Now, weight is effect of gravitational force on mass. So now they are just compressing, so they are not removing or adding the material. So mass will be same. Since mass is same, weight also will be same. So mass and weight in this case is independent of shape and size. So no change. Option D. Yeah. A student determines the density of copper. She has rectangular block of copper. Which other apparatus does he need? We know the density is mass by volume. So we need, so it's a rectangular block. So we can find volume using ruler. So balance and ruler. We do not need stopwatch. We do not need thermometer. C. A 0.15 kg mass is suspended from a vertical spring. The mass is pulled downwards until the spring has extended by 12 centimeter from its unstretched length. The spring constant of the spring is 30 Newton per meter. What is the magnitude of the initial acceleration of the spring when it is released? Okay, we know F equal to Kx, and from this we can find the force. Spring constant is 30 Newton per meter multiplied by extension is 12 centimeter. Either we have to convert the spring constant into centimeter or extension into meter, but final answers are given in meter. So we better convert extension to meter. So 0.12 into, instead of centi, I put 10 power minus 2. Okay. Now force is 3.6 Newton. With this, if you directly find the acceleration using F equal to ma, then you will be wrong. Why? Because the force acting, this is the force it want to act upward. But what we forget is effect of gravity also. So weight will be pulling downward, spring will be pulling upward. So we need to find the weight. We know that weight is mass into gravitation constant. So acceleration due to gravity. So it's 0.15 into 9.8. So it's 1.5 Newton. So the resultant force will be, there is upward force of 3.6 Newton up, then downward force of weight 1.5 Newton. So resultant force is 3.6 minus 1.5, which is 2.1 Newton. So this is the upward force. From this, we have to use F equal to ma. Acceleration is force by mass. So 2.1 divided by 0.15, which is 14 meter per second square. Option A. By the way, if you directly divide 3.6 divided by mass of the object, then you will get 24 meter per second square, which is wrong. Yes. A cricket ball of mass 0.15 kg is moving at a speed of 30 meter per second. The diagram shows the batsman holding a bat stationary as the ball hit the bat and bounce back with the same speed in the opposite direction. Ball is in connect with the bat for 1 into 10 power minus 3, 1 millisecond. Okay. The table shows the change in momentum of the ball and the magnitude of the force applied to the ball. Which row is correct? We need to find change of momentum. We need to find the force applied to the ball. We know that change in momentum is final momentum minus initial momentum. So mv minus u. Now we have to be careful with the sign of velocity. We can take any direction of velocity positive. In this case, if direction of approach is positive, then direction of leaving is negative. For convenient, if we take direction of leaving is positive, direction of approach is negative. So it's mass 0.15 into 30 final velocity going in this direction as positive minus initial velocity is then minus positive. Sorry, minus 30. So 30 final velocity minus of 30. So it's 30 plus 30, 60. 60 into 0.15 is 9 kilogram meter per second. Now we have found change in momentum. We also know that forces change in momentum by time. So if we want to find, we just have to take the time 1 millisecond and divide it with this value. So 9 divided by 1 millisecond, which is 9000 Newton. Option D. A stone is thrown vertically upward at a speed of 5 meter per second. All of the energy initially in the kinetic store of the stone is transferred to its gravitational potential store when the stone reaches its maximum height. Which equation gives the maximum height h reached by the stone? Okay. So it's given potential energy, all the kinetic energy is stored as potential energy. We know that potential energy is mgh, kinetic energy is half mv square. We can cancel m and m. So gh equal to half v square. We want to find h. So we just have to rewrite. H is v square divided by 2g. If we put the values, v is 5. So 5 square divided by 2 into g is 9.8. I think option C. Yeah. 3 energy resources are listed: geothermal, wind, nuclear fuel. Which resources get their energy from the sun? It's wind alone. Geothermal doesn't get its energy from the sun. It gets its energy from Earth's own gravity. Nuclear also no. So 2 only. A sample of substance has a shape that's determined by its container. What are the possible states of the sun? Okay. So only fluids, meaning gas and liquid, has the shape of the container. So B. A stationary smoke particle is hit by a fast moving nitrogen molecule. Which row describes the motion of the smoke particle and of the nitrogen molecule after the collision? It's Brownian motion. So both smoke particle and nitrogen molecule move, but smoke particle is bigger than nitrogen molecule. So nitrogen molecule will rebound. Right. A bubble of gas rises from the bottom of a lake to the top. The table shows readings of the gas pressure inside the bubble and the volume of the bubble. The temperature of the water in the lake is constant. The value in 3 rows of the table are correct and 1 row is not correct. Which row is not correct? Okay. We know that pressure and multiplication of pressure and volume, PV is constant. So we'll just find pressure and multiply by volume. We'll see what value it gives. First row is 360 multiplied by 2.4, which is 864. 270 multiplied by 3.2, also 864. 160 multiplied by 4.6, 736, not 84. It's not 864. 120 multiplied by 7.2 is 864. So option C is not correct. The diagram shows a glass flask sealed with a small volume of mercury in glass tube. When the flask is gently warmed, the mercury rises up the tube. What is the main cause of the movement of the mercury? Okay. Expansion of air. Okay. So this is slightly, um, we have to be slightly careful in this question. Why? Because Expansion of the mercury also one of the reason it can increase its height, but only the flask is heated, not the mercury directly. So the flask is heated, the air in it expand. As a result, it pushes the mercury up. So this is the main cause of the movement of the mercury. Even if you heat the mercury, it's going to expand and it increase. But compare the volume of the air and volume of the mercury. So expansion of the air in the flask. Option A. The diagram shows the equipment used in an experiment to determine the specific heat capacity of a metal. In the experiment, a heater is switched on for time t, yeah, t second, and increase in the temperature delta T of the block of the metal is measured in C, degree Celsius. Power supply, heater, PW, thermometer, insulator metal. Okay. Which equation gives a specific heat capacity of the metal? Two things are involved. Power involved, specific increase in temperature involved. We know that power is energy by time. From this, we can take the energy as power into time. Specific heat capacity. So energy is mass into specific heat capacity into change in temperature. Okay. So we understand energy given by the power supply is energy utilized to increase the temperature. So we can equate both energy. Power into time is mc delta theta. We just have to rewrite for the specific heat capacity. So if we rewrite m1 delta theta, go to the other side denominator. So C is P into T divided by m into delta theta. So option B. The diagram shows 4 rods. Each rod is made of different metal. P, Q, R, S. It's heated from X. Why does the ball on the silver rod fall first? Because silver is the best conductor of heat. A. 3 solid copper spheres X, Y, and Z are heated to the same temperature. X and Z are same diameter. Y is half of the diameter and white. Which row gives the order of the rate of emission of radiation? Okay. First, black is a good emitter than white. Second, higher the surface area, higher the rate of emission. So first, which one is black? Black and higher the surface area, which is X. So X will have highest rate of emission. Then both Y and Z are white, but Z has higher diameter, so it will have higher surface area. So X, Z, and Y. B. Which wave will diffract the most when passing through a gap that is 0.85 meter wide? Velocity is given, frequency is given. We need to find wavelength. With wavelength only we can tell. With frequency also we can tell, but with combination of velocity and frequency, we have to find the wavelength. In diffraction, greater the wavelength compared to the size of the width, greater the diffraction. So we'll find the wavelength. We know that V is F lambda, so lambda is V by F. We'll calculate the lambda of all values. Lambda equal to V by F. So we will calculate 300 by 280 is 1.07 meter. 300 by 400 is 0.75 meter. 350 by 280 is 1.25 meter. 350 by 400 is 0.88 meter. Out of this, C has the highest wavelength, so it will diffract more for the same gap or width. Yeah. B is amplitude. Seismic S wave is a transverse wave and perpendicular to the direction of the travel. Okay. Image of an object is formed by a plane mirror. In plane mirror, it's a virtual image because you can't project it in a screen, and it will be same distance from the mirror of the image will be in the same distance from the mirror as object from distance of object from the mirror. So it's D. Ray of light traveling in air is incident on an air glass boundary. Angles between the incident ray and the refracted ray are shown. Okay. Which equation is used to calculate the refractive index n of the glass? We know that refractive index is sine of incident angle divided by sine of refracted angle. So in this case, incident angle is actually not 50, it's 90 minus 50, which is 40. Similarly, refracted angle is not 64, it's 90 minus 64, which is 26. So it's sine 40 divided by sine 26, sine I by sine R. Option A. A small object O placed near a converging lens. Okay, lens forms image I. Okay, which statement is correct? Okay. If the object is placed near the focus length, then the rays will be parallel when they leave out of the lens. When the object is close to the lens, then they will be diverged when they leave out of the lens. Yeah. So option D. So the object is close to the lens, then the principal focus. That's why it's diverging. You know, speed of light is 3 into 10 power 8 meter per second. A ship sends an ultrasound pulse to the seabed to measure the depth of the sea. Speed of ultrasound wave in seawater is 1500 meter per second. Pulse takes 4 seconds to travel the seabed and back to the ship. What is the depth of? Okay. So we know that speed is distance by time, but in this case, distance is twice because it has to go to the seabed and get reflected and come back to the original position. So it's 2x by t. If we rewrite this equation for x, then we get speed and time divided by 2. So 1500 multiplied by 4.6 divided by 2. 3450 meter. Round off to 3500 meter. So C. Dolphin has a range of audible frequencies 150 hertz to 150 kilohertz. Which range of frequencies can be heard both by humans with good hearing and by dolphins? Okay. Humans have audible ranges 20 to 20 kilohertz. So it's dolphin can hear you only from 150. Humans can hear only until 20 kilohertz. So it's 150 hertz to 20 kilohertz. Both human and dolphin can hear. A positively charged balloon is placed against a wall. Charge makes the balloon stick to the wall. Positive charges on the balloon attract the electrons in the wall. This is right. Theoretically, this is right. But there is this positive is absence of electron in the balloon. Okay. So the net charge of the balloon is positive. A student is trying to determine the resistance of the lamp. He set up the incorrect circuit. So he tried to measure the resistance by V equal to IR, R equal to V by I. So he need voltage reading and ammeter reading, voltmeter reading and ammeter reading. Okay. So problem is voltmeter is in series. It has to be in parallel. So we will remove the voltmeter, we'll connect it, and we'll put the voltmeter parallel to the bulb. Disconnect the voltmeter and connect it to the parallel with the lamp. Super. A metallic wire X has a resistance. What is the difference in resistance for a wire with same material as X, shorter than X, but same diameter, same length as X, but with smaller diameter? Okay, we know that resistance is rho L by A. Rho is not going to change because it's the same material. Now, resistance is directly proportional to length. So, if we decrease the length, resistance should decrease. Okay, if you increase the length, resistance should increase for the same diameter. Similarly, for same length, if you decrease, it's inversely proportional to diameter square. So if we decrease the diameter, resistance should increase. If we increase the diameter, resistance should decrease for same length. So resistance of a shorter wire for same diameter, the resistance should be smaller. Resistance of a wire with smaller diameter, resistance should be higher. So resistance of a shorter wire is smaller, resistance of a smaller diameter is greater. So option C. Diagram shows a circuit for a potential divider. Which equation is used to calculate V1? It's going to be the same current through R1 and R2. So I1 and I1 equal to I2. We know that B is IR. From this, we can get I equal to V by R. Since I1 equal to I2, V1 by R1 is equal to V2 by R2. So if we rewrite this, V1 is V2 multiplied by R1 divided by R2. I think option B. Which electrical device is used to convert AC to DC is diode. A cell is connected to a parallel combination of 2 ohm resistor and a 4 ohm resistor. Current in 4 ohm resistor is 1 ampere. What is the current in the cell? Okay, total current in the cell, let's call it I. It will be I1 plus 1 ampere, I2. Okay. Now we will find the voltage across the 4 ohm resistor because we have current and resistance. That will be the same voltage across the 2 ohm, also across the cell. We know that V is IR. So it's 4 into 4 ohm into 1 ampere, which is 4 volt. Now we'll find the current in the 2 ohm resistor. We know the voltage across it is 4 volt. So I is V by R, 4 volt divided by 2 ohm. So it is 2 ampere. The total current in the cell is I1 plus I2. So 2 ampere plus 1 ampere, which is 3 ampere. Option D. It's going when there is electric current in long straight wire, a magnetic field is created around the wire. Straight wire carrying current into the page. So if this is the page, into the page. Okay. So into the page. So we have to use right hand thumb rule to find the magnetic field lines. So this is into the page. So it will be clockwise. So option B. Primary voltage supplied to a transformer is 3 volt, secondary voltage is 5 volt, and the secondary current is 2 ampere. The transformer is 100% efficient. What is the primary current in the transformer? Okay. In transformer, power in the primary is equal in power in the secondary. So V into I in the primary is equal to V into I in the secondary. VPIP equal to VSIS. Okay. We just have to rewrite this equation for IP, current in the primary. So it will be VSIS divided by VP. So it's 5 into 2 divided by 3, which is 3.3 ampere. C. When a thin gold foil is bombarded with alpha particles, some alpha particles are deflected through large angles. Which statement explains this deflection? More Actually, most of the statements are correct, but which explain this deflection? All positive charge and most of the mass of the gold atom are concentrated in small volume. That's why only some alpha particles are deflected through large angles. Most of the atom consists of empty space also, right? But that's not because only few deflected. That we can get from most of the alpha particles pass through. Okay. A detector near radioactive source shows a reading of 2000 counts per minute. How is corrected count rate determined? By subtracting the background radiation count rate. So it's D. Which statement about alpha, beta, and gamma radiation is not correct? Gamma radiation is least ionizing. That is correct. Gamma radiation is not deflected by magnetic field. That is correct. Beta particles are deflected most in magnetic field. That is also correct. Alpha particles are deflected most in electric field. That is wrong. Because in electric field also only beta particles are deflected most. So A is wrong. A sample of radioactive material has half-life of 20 minutes. Which statement is correct? After 30 minutes. Okay. Let's say that we have n number of samples in 20 minutes. One half-life, it will be half of n. So n by 2. After second half-life, one more half-life, it will be n by 2 divided by 2. So n by 4. It will be 1/4 of the initial value. After third half-life, 60 minutes, it will be again n by 4 divided by 2. So n by 8. 1/8 of original value. After fourth half-life, it will be 80 minutes. So Again, 1/16 of original. So after third half life, 60 minutes, it will be 1/8 of a material remains. So option C. Which statement is correct? The moon orbits Earth once in approximately 1 month. Stars are powered by nuclear reactions that releases energy. Nuclear fusion converts hydrogen into helium. Galaxy is moving away from the Earth at a velocity of 3000 km per second. What is the distance between the Earth and the galaxy? So we have to use the Hubble constant formula. H naught is V by D. D is V by H naught. 3000 into 10 power 3 meter per second divided by 2.2 into 10 power minus 8. 18. Sorry. So 1.36 into 10 power 24 meter per meter. Rounded off to 1.4. So option D. That's all. Bye. Thank you.